requires that a group of engineers work together as a team. This team of engineers is responsible for the safety of the pilots and passengers. While flying through the challenges the environment may produce, each engineer on the team has a specific skill set. They are the mechanical, structural, stress, aerospace, aerodynamics, electrical, and avionics engineer. The mechanical engineer figures out shape, size, and texture of the helicopter. They have studied the principles of engineering, physics, materials, science, of design, analyzing, manufacturing, and maintenance of mechanical systems. The mechanical engineer needs to be aware of the type of helicopter the customer wants and whether it's private or military use. They need to ensure the size of the eggshell will hold the correct amount of passengers and equipment. The eggshell is this part right here. All of the options the buyer can add on, like weapon mounts, extra fuel storage, and passenger seating. The engineer also researches design to make fuel efficient parts. Some of these parts may be used on the engine and fuel components. The structural engineer analyzes designs, plans, research structural components and structural systems to achieve the goals for the structure. This includes making sure the structure is strong enough to stay together and withstand any flight conditions. The structural engineer builds the eggshell, wings, body, and shape of the tail. The structural engineer also has to make it light enough to fly. The stress engineer is responsible for finding the stress points, manufacturing flaws, and safety features. Stress points are the weak points where two pieces come together. Some manufacturing flaws are if bolts are the right size or how old the bolts are. Some safety features may include locking mechanisms, seat belts, and parachutes. The structure is built, once the structure is built, the stress engineer fixes the stress points, looks for the manufacturing flaws, and checks the safety features. The aerospace engineer is concerned with the research, design process, development, construction, testing, and the science, technology of the aircraft. The aerospace engineer focuses on parts of the helicopter that would affect flight, like tail wings, propellers, and the flaps that control rotation. The tail wing shape is very important because it's like a stretched out raindrop. The shape is required because it splits the air while it's flying. Wind on the top slows down while on the bottom it speeds up, which causes lift. The propellers tilts left and right so the helicopter can turn. The reason for the tail propeller is the main propeller alone could cause the helicopters to spin out of control. So the tail propeller spins in the opposite direction. The avionics engineer designs and builds the avionics used on aircraft. Avionics are a type of electrical systems that powers the helicopter. Avionics include communication, navigation, and display that are fitted for the aircraft. If something is wrong with the electrical system, they will show the problem to the electrical engineer who will resolve the issues. The avionics systems are very important because they are a big part of the electrical system and rely valuably information for the pilots. The avionics systems allow the pilot to precisely control the helicopter while hovering, dropping off cargo, or in military airstrikes. The pilot uses a remote that looks like a long joystick that communicates with the flight computer. The pilot controls the main propeller, tail, and flaps that allow the helicopter to turn left or right and go up or down. The way the avionics systems control the helicopter is trademarked and can only be used by that company. The electrical engineer designs electrical systems that power aircraft. The person who designs the electrical circuits is also called an electrical engineer. They both create complex power systems, but one makes it for electronics and the other makes it for power plants, aircrafts, and spacecraft. The electrical systems provide radar tracking, power to the aircraft, light, lift, weather systems, and a lot more. They also analyze the amount of power in the aircraft. The tracking systems allow the pilot to track objects from both air and ground. In conclusion, helicopters are very complex and requires the dedication of the team of engineers. The engineers, through research and development, are able to design and manufacture a helicopter in months or less. I have learned a lot of interesting things about helicopter engineering. I hope you have too.
Poster board up on the stool, on the pink stool, and then point out what the pictures are. Careful of your plane, your helicopter. You can leave up and hold it for me. Watch the helicopter. Okay.
So, mechanical engineer, this is the shell. For the structure, it's kind of outside of the eggshell and the tail. This is the tail. This is what the wing looks like. This a stretch point would be one of these. You see the big bolt? If it would be rusted or it could be too small or too big. The tail, if you flip the propeller the same way as the tail, they would be spinning in the opposite direction. Right here, you see there are flaps right here that can control it so that it turns left and right. This is the joystick. It goes all the way down to the floor of the helicopter. On the buttons on the joystick control the propellers and this is the screen that shows the tracking. These two are very important not to get confused. There are pedals, and that's the engine of the helicopter. And that's how big one of the helicopters is compared to me.
But tell us about your passion. Why were you passionate about this particular